Welcome to solverfy.
So in this question, we are given two pulleys A and B. We have a force of 900 newtons to the left on pulley A. We're told the radius of these pulleys is 60 millimeters or 0.06 meters. We know the static coefficient of friction is 0.35. We're also told this is a V-belt problem with the angle of 36 degrees. And we're asked to calculate the maximum tension as well as the moments on this belt and pulley system. So let's start off by looking at pulley A. So we have a 900 Newton force to the left. And let's assume there's a force T2 this way and a force T1 this way. We know the angle between the belt and the center of the pulley is half a turn or pi radians. B is basically exactly the same with the same angle of pi. And so let's just look at pulley A. So if you look at pulley A, we have three forces, T2, T1, and 900 newtons. So we can solve our force equilibrium equation. So we have that the summation of forces is 0, where we have T2 plus T1 minus 900 is equal to 0. So that's our first equation. Now our second equation is an impending slip equation on belt A, and it's a V belt. So this equation will basically look like T2 over T1 is equals to E to the static coefficient of friction times the angle over sine of alpha, which is 36 degrees, over 2. So sine of 18 degrees. And that's our second equation. So from these two equations, we can determine T1 and T2. T2, which is our answer to B. And we can use that to determine the moments, which is our answer to part A. This is part A, this is part B. So from equation 2, we basically have T2 equals to 35.1 T1. Substituting that back into equation 1, we get 36.1 T1 is equals to 900 newtons. And so T1 is equals to 24.93 newtons. And T2, which is equals to the maximum tension that can be exerted on the belts, is 900 minus 24.93, which is 875 newtons. And this is our answer to part B of the question. Now to compute the moments for part A, we take the difference in the tension, so T2 minus T1 times the radius. So we take 875 minus 24.93 newtons times 0.06 meters, and we basically get 51 Newton meters, and that's our answer to part A. So basically for part A, we have 51 Newton meters, and for part B, we have 875 Newton.